In this video, let's see the main application of inverse Laplace transform. That is, we are going to solve a linear differential equation using Laplace transform. I'll explain the steps. Before that, these are the formulas. Laplace transform of y dash of t is equal to s into Laplace of y of t minus y of 0. This is the initial condition, and Laplace of y double dash of t is equal to s square l into y of t minus s into y of 0 minus y dash of 0. If you see the pattern here, if it's y dash of t, it's s power 1. Y double dash of t means s power 2. And then the consecutive signs are negative. S power 2 reduced to s and then only the constant. And then you can guess here. You can start with s cube minus s square minus s minus constant. This is the pattern. And see here, it is only the first term will have Laplace of y of t, then second term will have y of 0, then y dash of 0, then y double dash of 0. This is the pattern. Even if you see here L of y of t and then y of 0, y dash of 0. So slowly the derivative power will increase here, and what is the highest power? Y triple dash of t means I will start with s cube. Okay. Now I will explain the procedure. So the step 1 is, whatever the given differential equation, we have to express that in proper notation. And we have to arrange the differential equation if it's not in order. If it's completely proper, then the first step is you have to apply Laplace transform on both sides. Okay? And then we are going to use the set of formulas. I'll tell you what are those formulas. This we have seen, right? Laplace of y dash of t, y double dash of t, y triple dash of t, all these formulas we are going to apply. Then we have to apply the initial conditions so that we can simplify and write very clearly Laplace of y of t is equal to something. Okay. So L of y of t, we have to express it as a function of s. Then finally what we have to do? We have to find the inverse. These are the steps involved. Now see this problem. Solve by using Laplace transform d square y by dt square plus k square y is equal to 0, given that y of 0 is equal to 2 and y dash of 0 is equal to 0. So this is the differential equation and these are the initial conditions. So they will give the initial conditions depending on this differential equation. Okay. So what is this first step? We will write it in this format. Okay. So instead of writing d square y by dt square, I will write y double dash of t plus k square into y of t is equal to 0. So this is your first step. Arrange it in the proper common order. And then you are going to take Laplace transform on both sides. This is your step 2. So L of y double dash of t plus k square is just a constant, we can take it out. K square into L of y of t is equal to Laplace of 0. So this is the second step. Okay, we have applied Laplace transform on both the sides. Now you have to use a formula. Correct? That's the third step. What is L of y double dash of t? I clearly told you y double dash means it will start with s square. Leave some space, minus s. Leave some space, minus some constant will be there. Just stop with the minus and then again we will start from here. First term L of y of t minus y of 0 minus y dash of 0. Okay. So if it is L of y double dash of t, then how many terms will come? 3 terms will come. Okay. And this is Laplace of y of t only, so we can write it as it is. Same like Z transform. We are going to group the terms clearly and we have to write what is Laplace of y of t and as a function of s. So now L of y of t is common for this term and this term. So I will take common. So s square plus k square into L of y of t. Okay. Minus 2s. Why we got 2s? Because they have given y of 0 as 2, so I have written. What is y dash of 0? This value is 0. So this value is 2 and this value became 0. So we got minus 2s is equal to 0. Now it's more easy. I'll push that minus 2s to the other side. So it will become plus 2s and s square plus k square will come to the denominator. Now we have got Laplace of y of t as a function of s. This is the fourth step. And finally fifth step, we have to apply inverse on both the sides. What is the formula? Laplace inverse of s by s square plus a square is cos at. In the place of a I have k, so cos kt. Okay, this 2 is there outside, so 2 cos kt, because 2 I do not want for that formula, I want only s by s square plus k square for the formula, so 2 cos kt is the solution for this differential equation. Y of t is equal to 2 cos kt. Normally what you might have studied, this is a second order differential equation, then you will write auxiliary equation, and right hand side if any value is there you will find particular integral and all those things, right. That is the procedure to solve a second order linear differential equation in an analytical way. So, of course, we have seen numerical methods also to solve this, and now this is another way we can also solve this by using Laplace transform. So, in this case if it is y triple dash, already we have your formula, right. So, we can try one problem. Yes, see this problem, solve y triple dash plus 2y double dash minus y dash minus 2y is equal to 0. So, how many initial conditions they have to give? 3 conditions, that is y of 0, y dash of 0, y double dash of 0 is required for the formula. So, they have given y of 0 and y dash of 0 both as 0. The equation will shrink, okay. So, do not worry about it, and y double dash of 0 they have given it as 6, okay. And what is the formula? Y triple dash means, how I will start? S cube minus s square minus s minus constant. That is the procedure, right. So, first step we will, already it is in order. So, I will write it in terms of t, y triple dash of t plus 2 y double dash of t minus y dash of t minus 2 into y of t is equal to 0. Now, taking Laplace transform on both sides, that is the next step. So, Laplace of y double dash of t plus 2 into, sorry, y triple dash of t plus 2 into Laplace of y double dash of t minus Laplace of y dash of t minus 2 into Laplace of y of t is equal to Laplace of 0. Now, we are just going to apply the formula. So, for y triple dash, already I have given you the formula, s cube L of y of t minus s square y of 0 minus s y dash of 0 minus y double dash of 0. For the second term, plus 2 into s square L of y of t minus s into y of 0 minus y dash of 0, the last term, and then minus y dash is there. Y dash, what is the formula? S into L of y of t minus y of 0. Again finally minus 2 into only y, so L of y of t. So, this is equal to 0. So, you have applied Laplace transform on both sides, and also you have used the formula. Now, what you have to do? You have to substitute the initial condition. So, in initial condition, wherever y of 0 and y dash of 0, it will become 0. So, those terms you can mark it in pencil and cross it. Now, what we will be having is, all the terms will be having Laplace of y of t, except the last term, that is y double dash of 0 is 6, no, except that term, all the other values will have L of y of t. So, we have taken common, s cube plus 2s square minus s minus 2. You have to simplify this on your own, then again minus 6 is equal to 0, okay. So, I can even more precisely tell you, if you see this, oh my god, why it's so blurred? If you see this, y of 0, this is 0, y dash of 0, this is 0, only this term will have 6, okay. Then s cube L of y of t. So, L of y of t if I take common, s cube will be there. Then again plus 2 s square L of y of t, this is the second term, L of y of t term I am saying, and then minus s into L of y of t, this is the third term. So, minus s will be there. Finally, minus 2 into L of y of t will be there, correct. So, L of y of t, by taking it common, we got all these values, and then finally this y double dash of t 0 is there, right. This term will have minus 6. Now, we are going to simplify these terms. So, this minus 6 I will push it to the other side. So, it will become plus 6, and this we can simplify, right. We can take s square common from these two terms. So, I will have s plus 2. I can take minus 1 common from these two terms, again I will get s plus 2. Now, this s plus 2 and this s plus 2 I am taking common. So, s plus 2 into s square minus 1. We have just factorized it, and then right hand side 6 is there. Now, I am going to push this down. So, L of y of t is equal to 6 by s plus 2 s minus 1 into s plus 1, because s square minus 1 I have written it as s minus 1 into s plus 1. Now you remember, this is a problem in finding inverse by using partial fractions, correct? So we are going to use partial fractions technique to split these terms. So I am going to take this separately as a problem, 6 by s plus 2 s minus 1 s plus 1. How I will split? A by first term plus b by second term plus c by third term. And remember, you will take LCM, correct? So when you take LCM, what you will get? 6 is there on the numerator on that other side. Whichever term is missing, we will multiply with that in the numerator. S plus 2 is there, so which is missing? S minus 1 s plus 1, so I have multiplied. Here s minus 1 is there, which is missing? S plus 1 and s plus 2 I have multiplied with b. And then for C term, s plus 2 and s minus 1 is missing, I have multiplied. Now I have to substitute suitable value to find a, b and c. So if I substitute s as 1, then a will become 0 and c will become 0, I will get b. So we got b. And if I substitute s as minus 2, I will get a, b will become 0, c will become 0. So put s is equal to minus 2, 6 is equal to 0 plus b into minus 2 plus 2. So this term will become 0, and then this term also will become 0. So only you will be having the first term, okay. So 6 is equal to a into minus 2 minus 1 and then minus 2 plus 1. So what you will get? A into minus 3 minus 1. So you got a. Similarly, if I substitute s as minus 1, then I will get 6 here, and this term will become 0 and this term will become 0. C into minus 1 plus 2 minus 1 minus 1. So what I will get? 1 into minus 2. So I will get C. So now you got A, B, C. Simple. You are going to substitute it over there and you have to apply inverse. So what is Laplace inverse of the whole thing? So we will write the first constant A, okay. Laplace inverse of 1 by s plus 2. What is the formula? Laplace inverse of 1 by s minus a, e power at. So in the place of a I have minus 2, because s plus 2 I can write it as s minus minus 2. Your general formula is L inverse of 1 by s minus a is e power at. So 2 into e power minus 2t. And the second term b is 1. So Laplace inverse of 1 by s minus a, same formula. In the place of a I have 1, e power 1t. Again minus 3 into, in the place of a I have minus 1, same formula. So minus 3 into e power minus t. So you can write it down that we have used the formula Laplace inverse of 1 by s minus a is equal to e power at. Okay. So this is how we will solve differential equations by using Laplace transform. So step 1 is write it in format, step 2 is apply Laplace transform, step 3 is apply the formulas as well as after that initial conditions, then simplify Laplace of y of t is equal to something. We have to express Laplace of y of t as a function of s like this, and finally you have to take inverse to find y of t. So we got the solution also. So here we have solved y triple dash, that is third order differential equation by using Laplace transform. Now see this question, solve y double dash plus 6y dash plus 9y is equal to 12t square e power minus 3t. They have given the initial conditions, y of 0 is equal to 0. Also they have given y dash of 0 is equal to 0, which is not visible. So I will write here y dash of 0 is equal to 0. Now we have to write this equation in order, right? So y double dash of t plus 6 into y dash of t plus 9 y of t is equal to 12t square e power minus 3t. So right hand side always some simple function will be there. Now this is slightly bigger function compared to that. Okay, so second step is you have to apply Laplace transform on both sides and we can take out the constant. So Laplace of y double dash of t plus 6 into Laplace of y of t plus 9 into Laplace of y of t, that's equal to 12 into Laplace of e power minus 3t t square. Just we have applied Laplace transform. Now we are going to use the formulae. Keep this in mind, y double dash. So I will write s square, leave some space minus s, leave some space, put a negative sign. leave it. Now we are going to fill those terms, L of y of t first term, minus y of 0 second term, y dash of 0 third term. And then the second term is 6 into L of y dash of t. So 6 into, since it's y dash, I will start with s power 1. S power 1 L of y of t minus y of 0. And final value is 9 into Laplace of y of t. Now, what you will be having on the right hand side? Which property you will be using it? Remember, we have done these small problems in the beginning itself. Laplace of e, whatever term is there on the right hand side, I have written that separately. Laplace of e power minus 3t into t square. Now this is by using property 1. Laplace of e power at f of t is f bar of s minus a. Okay. So s minus a means in the place of e power at I have e power minus 3t. In the place of a I have minus 3. So s minus a is s minus minus 3. So it will become s plus 3. Now what I will do, I will write Laplace transform of this function along with e power at whatever it is there, and wherever s is there I will change s plus 3. So what is Laplace transform of t power n formula? N factorial by s power n plus 1. So 2 factorial by s power 2 plus 1, that is 2 factorial by s power 3. Now wherever s is there I will replace s plus 3. So this is your solution, 2 factorial by s plus 3 the whole cube. So initially I have done so many small problems in those videos, the beginning of Laplace transform. So first go through all the videos, then it will be easy for you to solve the Laplace transform of any function. Even right hand side you may get a unit step function, right hand side you may get a discontinuous function. We already know how to take Laplace transform for a unit step function or a discontinuous function. So whatever we have studied so far in Laplace transform, we are using it here. And in inverse also same, completing square technique can be there, or partial fractions will be there. Most of the time partial fractions only will be there on the right hand side. Okay. And now we are going to apply initial condition. Okay. After applying the formula, what is the initial condition? Y of 0 is equal to 0 and y dash of 0 is also 0. And right hand side, it's the same whatever I told you, 12 into 2 by s plus 3 the whole cube. This is what we have solved on the right hand side. So in the left hand side, what are the things we are going to take common? In Laplace of y of t, what are the terms? S square is the first term, correct? And then 6s of L of y of t, this is the second term, s square plus 6s. And third L of y of t is this, 9 into L of y of t, so plus 9. And right hand side we have 12 into 2, so we have 24 by s plus 3 the whole cube. Okay. So what is L of y of t? I will push this down. So L of y of t is 24 by s plus 3 the whole power 5. Now inverse, you remember the same technique we are going to use it. Here we shifted, right? Here we are going to shift back. So Laplace inverse of 24 by s plus 3 the whole cube. We are going to shift back s plus 3 to s. So what you will do, you will multiply with e power minus 3t, same formula. So 24 into e power minus 3t, L inverse of 1 by s power 5. So we shifted s plus 3 to s, we replaced s plus 3 to s, and we multiplied with e power minus 3t. And even if you forget the formula, I told you one shortcut. If it's plus here, then here minus sign will come. If it's minus here, here plus. If it's s minus 3, I will get e power 3t. Okay. And what is Laplace inverse of 1 by s power 5? So this is nothing but t power 4 by 4 factorial. Same formula we are using, that is Laplace of t power n is n factorial by s power n plus 1. So since the factorial value won't be there in the numerator, we are dividing it. You can just go through the Laplace inverse formulas. So we got this answer. In Laplace transform as well as Z transform, without knowing the formula, solving a problem is very tough. It is a very small problem, but if you have learnt your previous problems and techniques properly, then it will be very easy for you. And as I told you, you may get a unit step function on the right hand side or a discontinuous function. For that, practice more problems. Thank you.